All right, so if we're gonna go any further, one of the things we need to do is we need to talk about we have to talk about negative exponents, right? And the thing with negative exponents is I have to talk to you about them before we go through division, but they're kind of hard to understand without knowing a little bit about how division plays into this. So you're gonna kind of get a few things thrown at you that you're not really ready for, but that's just, and it's kind of how we have to do it. So we're gonna do it anyway, and hopefully you'll figure it out and you'll get through it okay. All right, so let's move forward here. It says negative exponents are used to show that a number is being raised to a power, but in the opposite position it is in on a fraction. All right, so that sounds really confusing. So I'm going to, before I do these examples, I want to try and show you something. Supposing that I have 2 to the third, and I'm going to divide it by 2 to the 7th, okay? Now, it would be really easy to go, okay, well, you have 8 over whatever 2 to the 7th is, which is like, I want to say 256, right? So it'd be really tempting to do that, but instead of doing that, let's blow up these expressions and see if we can simplify them first before we have to do any big multiplication and division. So I can rewrite this as 2 times 2 times 2, right? And then I can rewrite this one as 2 times 2 times 2 times 2 times 2 times 2 times 2, right? And I've got, so I've got 3 2's here, 1, 2, 3, and I've got 1, 2, 3, 4, 5, 6, 7 of them down here. So think about what you know about division and what you know about fractions. Well, I know that if I have the same thing in the numerator and the denominator, that the word that we use regularly is cancel out. We say they cancel out, and that's kind of it's misleading. Probably a better phrase is to say they equal 1, right? Because anything divided by itself, not just 2, but anything divided by itself equals 1. So what happens is this you can rewrite just as 1, right? And you can do the same thing with this. You can rewrite this as 1, and you can rewrite this as 1, right? And so you wind up on top with this, and you have all these 1s down here, right? So here's the thing. You multiply 1 by anything, it doesn't really change anything. So most of the time, if you're multiplying 1 by something, we just get rid of it, right? So that's where the whole cancellation thing comes out, that they kind of wipe each other out, right? And so with this particular problem, all my 2's go away on top, and then I'm left with 4 of them in the bottom. So I have to have something on top, so that's where you do use 1 almost as a placeholder. And then you have 2, 2, 2, 2. You got 4 of them right there. So you got 1 over 2 to the 4th, right? Now, think about this for a second, right? What did we do, and how can I write this, all right? Now, if I go 3 minus 7, right? If I do 3 minus 7, I get 2 to the negative 4th, and that's not what I have. I have 1 over 2 to the 4th. But what a negative exponent represents is it represents that it is in the opposite place in the fraction that it's in currently. So if you think of 2 to the negative 4th as 2 to the negative 4th over 1, this is telling me that, hey, we're going to move it down over here, and then when we move it down over here, it becomes 2 to the 4th, and then this just becomes 1 up here, right? And so that's kind of how this equals this. All right, so if that helped, great. If it doesn't, yeah, I apologize, but we're just going to move forward. All right, so same thing here. We have 3 to the minus 4th, right? So we're going to put that over 1. And so this means that this is going to go down in the denominator and become 3 to the 4th power. And seeing as I have nothing up top, I got to put 1 in kind of as a placeholder. All right, and then we figure out 3 to the 4th is 81, all right, because 3 times 3 is 9, We have another 3 times 3, so those are my 4 3s. That becomes 9, and 9 times 9 is 81. So we have 1/81st. All right, same thing with this one right here. We're going to put that over 1. We're going to move that down into the denominator, and it becomes 9 squared, 1. And then this one, coincidentally, happens to be the same thing. Trust me, all of these do not work out to be 1/81. So let's try a couple more of these, all right? So when we work with, actually, you know what? I'm gonna go back here, and we're gonna, instead of moving on to that, we're gonna just kind of do a few more. So let's do, let's say what happens if we have 7 to the negative third power, right? So that would be 1 over 7 to the third, which is 1 over 7 times 7 times 7, which is 49 times 7, which gives us, not 6, 3, which gives us 343. So you get 1 over 343. Right, let's do one last one. Let's say I have 2 to the negative 5th power. All right, so if I have that, that's 1 over 2 to the 5th. Okay? And so you get 1 over 32. Now, something you'll see that Alex likes to do, which is really, really annoying, is they'll do stuff like this. They'll say, hey, you have 1 over 3 to the negative 2. And you'll be like, what? You know? So the thing I want to iterate is that just because an exponent is negative, it doesn't mean that it's automatically going to the denominator. If it's already in the denominator, it means it's changing position, right? So it's going to its opposite position, which in this case is going to be up top. So for this one, this would become 3 squared. And then you could say it's over 1, but you really don't need to write that, right? So it's just 3 squared, which is 9. Right? Similarly, if I have, let's say I have 3 over 4 to the negative third power, right? If I have that, then that's going to be 3 times, because this is going to change position, 4 to the third, right? Which is 3 times 64. 4 times 4 is 16. 16 times 4 is 64. And then 3 times 64 is 192. Right? So you will see some problems like that, and quite a few actually, where they put negative exponents on terms that are in the denominator. And so what that means is they move up to the numerator then. So it's going to go to the opposite position that it's in. So if it's in the numerator, it's going to the denominator. If it's in the denominator, it's going to the numerator. All right, so I hope that makes a little bit of sense. That's going to kind of inform everything that we're going to do moving on. So I'm going to pause the video here, and we're going to pick up with the next page that I tried to go